In this video, we're going to go through an application of quadratic residues. Let's have a look at our first question here, which says find the possible values of x squared mod 9. Okay, so what are the remainders when we square values and then divide them by 9? That's essentially what it's asking, or the quadratic residues modulo 9. So let's set up our table. So I'm going to write x, and then our next row is going to be x squared because that's the calculation we're doing. And then our final row is going to be our final answers, which are x squared mod 9. Now let's think about the most efficient way of doing this. Let's take our mod, which is 9, and we're going to divide by 2, which gives me 4.5. So in terms of my x row, I shouldn't have to go above 4.5 because of the symmetry of our quadratic residues. So therefore for x, I'm only going to consider 0, 1, 2, 3, and 4. I don't have to go to 5 because that's above 4.5. And the quadratic residue for 5 should be the same as our mod 9, subtract 5, which gives 4. Okay, so you should get the same value for 4 as you do get for 5, so therefore I shouldn't have to go above 4. So let's start filling it out then. So let's do the x squared row. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now let's calculate the remainder when we divide all of these by 9. Well, 0, that's smaller than 9, so it should be its own remainder when divided by 9. We can say the same about the 1. We can say the same about the 4. And then we get to 9. Well, the remainder of that when we divide it by 9 will be 0 because 9 is a multiple of 9. And in 16, the remainder would be 7. So now we can use our bottom row to write out our answers. Okay, it's any unique value in this row. So the quadratic residues modulo 9 would be 0, 1, 4. I don't have to write 0 again, so the other one would be 7. And those would be my final answers to the first question. So I've got my answer to question 1 over here. We're now going to make use of this to answer some related questions. So if we have a look at the second one, it says find the possible values of 2x squared mod 9. So essentially, if I do the calculation 2x squared, what is the remainder when we divide by 9? Now let's consider the difference with the first question. So the first one asked for just x squared. Well, in order to get from x squared to 2x squared, we would have to multiply by 2. So let's consider some of our properties of congruence relations. If we have A is congruent to B mod n, then what we can do is multiply both sides of our congruence relation by any integer. So we can multiply both sides by 2, so we would get 2a is congruent to 2b mod 9. So therefore, if I want to work out the remainders for this second question here, all I need to do is go to the first question and multiply all our remainders by 2. So let's go through that. I'm going to write 2x squared mod 9. And now let's go to our original remainders up here and multiply them all by 2. So if we look at the first one, we've got 0. So 0 times 2 would just be 0. So that's one of my answers. Then we got 1. 1 times 2 is 2. So that's another one of my answers. Then we got 4 multiplied by 2 would give 8. So that's another answer. And then finally we got 7. Well, if I multiply that by 2, I would get 14. However, that number is bigger than 9. Okay, so what is the remainder of 14 when we divide by 9? Well, that would be 5. So actually, I'm going to write a 5 in instead as we try to give our least positive residue, or if we're including 0, it's the least non-negative residue. So 0, 2, 8, and 5 should be our final answer to the question. Let's have a look at our next one. So question 3 says find the possible values of 2x squared subtract 4 mod 9. So essentially what it's asking is if you do the calculation 2x squared subtract 4 for any integer, what is the remainder when we divide by 9? So once again, let's consider how this is related to what we've already done, where if we compare this to the previous question, for that one we had just 2x squared. Now we've got 2x squared subtract 4, so essentially we have to go to the previous question and just subtract 4. Because one of our rules of congruence relations is that if we have A is congruent to B mod n, then we can go and subtract or add the same number from both sides and the statement's still true. So we could do A subtract 4 is congruent to B subtract 4 mod n. So let's go to our remainders from the previous question, and we're going to subtract 4 from them. So I'm going to create a row which I'm going to title 2x squared subtract 4, and then we're working mod 9. And we're going to go to our remainders from the previous question, and we're going to subtract 4 off all of them. So if we start with the 0, 0 subtract 4 would give me negative 4. However, we're not going to leave this as negative 4, because we want this value to be anywhere from 0 up until 1 less than our mod, which is 8. So what I can do is add on our mod of 9 to negative 4. Okay, so that's going to give me positive 5. So negative 4 is congruent to 5 in mod 9. So in place of a negative 4, I'm going to write a positive 5. Now let's go to our next remainder from the previous question, which was 2. And if I subtract 4 from that, I get negative 2. Now once again, this is negative. I don't want that. So I'm going to add our mod 9 onto it, which is going to give me 7. So negative 2 is congruent to 7 in mod 9. So I'm going to replace the negative 2 with a 7. Let's move on to our next remainder, which was 8. If I subtract 4 from that, I will get positive 4, which is the least non-negative residue, so that's fine. And then let's move on to the 5. If I subtract 4 from that, I'd get 1, which is once again the least non-negative residue. So then we're done. Our answers to this third question would be 5, 7, 4, and 1. Let's have a look at our last question. So our last one says find the possible values of x to the power of 4 mod 9. So essentially what this is saying is if you take any integer and raise it to the power of 4 and then calculate the remainder when we divide by 9, well, those would be my answers. So let's think about how this might relate to one of our previous questions. Well, the one this is going to be directly related to would be the very first question. Because in the first one we had x squared. So what's the relationship between x squared and x to the power of 4? Well, if you go to x squared and you square it, you're going to get x to the power of 4. Okay, because if you take x squared, raise it to the power of 2, well then you'd have to multiply your powers, and that would give you x to the power of 4. Therefore, I can go to the remainders of the very first question up here, and if I square all of them, I'm going to get the remainders for x to the power of 4. And in terms of which rule we're using of congruence relations, well, if A is congruent to B mod n, we can raise both sides to the same positive integer power. So therefore, we can square both sides. So A squared will be congruent to B squared mod n. So let's go through and do that. So let's create a row that's going to be titled x to the power of 4 mod 9, which are going to be my answers. And we're going to go to the remainders for x squared and square them. So let's start with the 0. If we square 0, we just get 0, which is the least non-negative residue. So I'm going to write that in. Then if we go to 1 and square it, we get 1, which is smaller than 9. So once again, that's fine. Then if we go to the 4 and we square it, we get 16. However, that value is greater than 9. So let's get the least non-negative residue by subtracting 9 off it, which would give me 7, which would be the least non-negative residue. And then finally, let's move on to the 7. And if we square that, we get 49, which is clearly bigger than 9. So we have to subtract away multiples of 9 until we get the least non-negative residue, which would be 4. So I'm going to replace the 49 with a 4. And those would be my final answers. So the remainders, where we calculate x to the power of 4 and then divide by 9, would be 0, 1, 7, and 4.